This is Algebra 2, Lesson 10-13, add and subtract with unlike denominators. Today's date is Thursday, May 7th, 5/7, 2020. Our objective today, as the title implies, is to add and subtract rational functions when they do not have like denominators. So let's start with just numerical fractions without any variables to see what we would do. So in the case when I have 1/3 plus 1/6, I need to first make sure that they have the same denominator, and then I can add like we did in lesson 10-12 yesterday. So for this one, I could multiply the left fraction, and you don't want to write this one down yet, by 6/6 and this right fraction by 3/3. That is a surefire way of always getting this to work out. You just multiply by the denominator of the other. So if I did 3 times 6, that's the same thing as 6 times 3, so these two numbers must be the same. But there's an even easier way. The easier way of doing this would just to be multiplying the left fraction by 2/2. If I do that, that turns into 1 times 2 is 2, 3 times 2 is 6. The left fraction is now 2/6, which is the same thing as 1/3, plus 1/6. And now they have the same denominator, and I can add just like we did last time. The denominator stays the same, and 2 plus 1 is 3, and then always make sure to reduce it at the very end. So 3/6 is the same thing as 1/2, and I get my final answer. Let's try one where I do have to multiply by the denominator of the other for each of these fractions. So I want to get, again, the same denominator here to get like denominators. So between 3 and 5, the closest thing I can do is 15. I can multiply them by each other. So I see a 5 down in the bottom right, so I'm going to multiply the left fraction by 5/5, and I see a 3 down here in the bottom left, so I'm going to multiply this 2/5 by 3/3. When I do that, this blue fraction, 1 times 5 is 5, 3 times 5 is 15, plus, okay, 2 times 3 is 6, and 3 times 5 is 15, and we have accomplished our goal of getting the same denominator. It's now 15, and then I just add the numerators and keep the denominator, so the denominator is still 15. 5 plus 6 is 11, and we have our final answer. I can't reduce it any farther. I'm always checking at the very end, can I reduce it any further, and I can't. Okay, so what's the general procedure here when we have just numbers? So when you have unlike denominators, you first are going to get the denominators, or getting like denominators. How? By multiplying each fraction by the denominator of the other. And then you can add and subtract just like when you have like denominators from last lesson. Notice that we didn't exactly do that over here because there was a shortcut, but you could still have done the same method. It just would have meant you had even more reducing to do. So let's see a few examples of these. I think I did, oh, oops. All these example numbers are off on this one for some reason. This should be example 1, 2, and 3, and I think that's all we had from today. Here we go. So example number 1. Okay, obviously we can't add these two fractions because these are not the same terms, the different binomials. So I'm going to multiply this left fraction by the denominator of the other fraction. It's going to be x minus 4 in the numerator and x minus 4 in the denominator. And then for the second fraction, I have x plus 1 down here, so I'm going to multiply by x plus 1 and x plus 1. So what's going to happen up here in the blue? So this 3 is going to be distributed into both of these two terms. So I'll have 3x, maybe I'll write it underneath because otherwise I'm going to run out of room over here. So I'll have 3x, and then 3 times -4 is -12. And then all of this is divided by, okay, so this is kind of the key thing with all of today's lesson and for future lessons whenever we are trying to get like denominators. Don't multiply these out unless you absolutely need to. 99% of the time, just leave them factored. Leave this x plus 1 times x minus 4. Don't actually multiply. I mean, it's easy to multiply them out. You can either use the box method where you do that thing, or you can use FOIL. Either way, just leave it as much as possible. Less work for you, right? Okay, then I still have the plus symbol, just copying that down. Okay, then I'm going to, again, distribute this 2 into the x. That's going to be 2x, and then 2 times that 1 is going to be 2. and that's all going to be divided by, leave this as, it can be x minus 4 times x plus 1, but I can switch those. It's being multiplied, doesn't matter, so I'm going to say x plus 1 times x minus 4. Okay, so now check it. We have the same denominator. We have like denominators. I can go ahead and add the numerators. So the denominator here is still going to be x minus 1 over an x minus 4. So these are both in the denominator. And what's in the numerator? I'm going to add 3x and 2x. I'm adding those together. So I'm going to get 5x. And then I have negative 12 plus 2. That's a negative 10. And normally you'll be done, but you should always check, ooh, maybe I can factor that. Oh, look, see the numerator, you can factor out a greatest common factor of 5. So I can say, okay, I might be able to factor some more. Let's check. If I factor out a 5, what's left over? I have an x minus 2, and this is still being divided by x minus 1 and x minus 4. Okay, see, if I had an x minus 2 in the numerator and denominator, I could have crossed them off, but I don't. They're all different, so I can either type in this answer or this answer. Both of them are fine on Khan Academy. Let's look at another example. So there's nothing too special. Again, it's going to be the same procedure. I'm just going to be multiplying by 6a squared over 6a squared, 6a squared over 6a squared. And for the second fraction, I'm going to have a plus 2 and a plus 2. I'm always looking at the denominator of the other fraction. Okay, so what happens when I do 6a squared? So I'm kind of thinking of this as distributing the 6a squared into both of these two terms. So I'm going to first do 6a squared times 3a. So again, multiply coefficients. 3 times 6 is 18. And then a squared times a. How many a's do I have? Well, I had 2 and then another one, so I have a total of 3, so a to the power of 3. And then distribute into the negative 1, and I just get negative 6a squared. What about the denominator? The denominator is the quantity of a plus 2. That 2 got a little bit messed up. A plus 2 times 6a squared. Okay, copy down the symbol. I have a plus symbol. And then this one is going to be a little bit harder because I'm multiplying a binomial by a binomial. It's this quantity of 2a minus 1 times the quantity of a plus 2. So let's do some scratch work off to the side. Whenever I multiply binomials, I can either FOIL or I can do the general rectangle. I like doing the box method. I don't know what we're calling it, but doing this thing is a little bit easier for me to do. You can do it by doing FOIL, first, outer, inner, last. I'm doing 2a minus 1 and a plus 2. So 2a times a is 2a squared. A times negative 1 to get this cell right here is negative a. And then 2a times 2 to get this cell right here is 4a. And finally, this cell is negative 1 times 2, negative 2. When I add all these together, I get 2a squared, 2a squared. And notice that these diagonals are like terms. So I have 4 a's, and then I subtract one of those a's. So I have a total of 3 a's. So plus 3a. And then finally, minus 2, minus 2. Notice the denominator. I'm going to kind of switch them a little bit. I'm going to do the a plus 2 first, just so it looks the same as the other ones. So it's going to be a plus 2 times 6a squared. And we now have like denominators, and I can go ahead and add them. So when we add, let's add all the a cubes first. That's the highest degree that I see in all the numerators. And there's only the a cubed term. So I'm going to rewrite 18a cubed. Let's add all the a squared terms next. So I have 2a squared and a negative 6a squared, and those are the only two. So negative 6 plus 2 is negative 4, so I have a total of negative 4a squared. Negative 4a squared. Let's add all the a terms left. Okay, there's only this left. Like, we've used up both those terms, so I just have that 3a, so plus 3a and minus 2. And the denominator, I just copy it down again. It's the a plus 2 times 6a squared. Is there anything that I can factor up here? I might be able to do factoring by grouping. Let's see. No, I can't, because if I kind of think of this as a fraction, 18 and 4, and factor out a 2, you don't get anything similar to that. Okay, so that's as far as I can go. And go ahead and box it. And again, yeah, typically in Khan Academy, you're not going to be able to reduce them at all. So our final example, we have this thing down here, and it's the same procedure yet again. So, I did want to clarify this point. Like, it doesn't matter what order these are written in. You could have written them backwards, and it will still be right. You're allowed to switch if they're being multiplied. All right, so I'm going to multiply this left fraction by the denominator down here, 3z plus 2, 3z plus 2 over 3z plus 2, and the right fraction by 2z minus 1 all over 2z minus 1. So again, I'm going to kind of think of this as distributing this 6z cubed into each of these terms. So 6 times 3 is 18. Z cubed times z is z to the 4th. Again, kind of think of them as adding the powers. If you don't have a power, you assume it's 1. 1 plus 3 is 4. And then distributing into this 2. 2 times 6 is 12. So notice it's a plus sign, so it's going to be plus 12. And then still z cubed. The denominator, which will eventually be a like term, is 2z minus 1 times the quantity of 3z plus 2. The next fraction, the next rational expression that we're dealing with, I'm going to go ahead and copy down the plus sign. I guess I should have done a minus sign for one of these, just so that you remember, oh, if you have a minus sign, you have to distribute it into all of the terms here. But I think you guys probably remember that from the previous homework assignment. So how do I do this one? This one is nice and easy. Again, just distributing into our binomial. So 5z to the power 4 times 2z, and it's going to be 10z, and then 4 plus 1 is 5, so 10z to the power 5. And then distributing into the second part of the binomial, we have minus, just copying down the sign right here, minus 5z to the power 4. And that's all going to be divided by the same terms, 2z minus 1 times the quantity of 3z plus 2. Alright, and we have like denominators. We have accomplished our goal, and it turns into a homework assignment very similar to 10-12. Just go ahead and add the numerators together. So let's add the highest degree first. So this is the highest degree. There's no other z to the power of 5, so I'm going to just say 10z to the power of 5. Let's do all the z to the power of 4. So I have a negative 5 there and a positive 18. So that's going to be a positive 13 when I add those two together. So I have a positive 13z to the power of 4. And finally, the only term that I haven't used up is this 12z to the power of 3. So plus 12z to the power of 3. And that's all going to be divided by the same thing, just copying it down. So 2z minus 1. That quantity times the quantity of 3z plus 2. And I noticed that there is a greatest common factor in the numerator. I could factor out a z to the power of 3, but if I factor that out, there's nothing that's going to cancel out here with the denominator, so there's nothing really I can do, and I'm going to go ahead and call that my final answer. Yeah, so I know that these types of problems can get tricky, especially when you're multiplying binomials by binomials. It takes a little bit of review. But that's the lesson for today. So that concludes Algebra 2 Lesson 10-13. I'll see you guys tomorrow.